Hi everyone. Today we're going to be going over Mentor 7 question 2 together. So this question kind of has to deal with Mentor 7 question 1, which is our Pokemon selector questions, and again kind of deals with some data abstraction questions. Okay, so let's go ahead and start by just reading through the questions so we know it is what we're going to want to do here. Okay, so this question says, this function returns the correct result, but there's something wrong with its implementation. What's the issue and how can we fix it? Okay, just by reading that, we know we're going to be getting a function coming up that is something we can use on these Pokemon instances that we created in the last problem. But something about the implementation, while it currently does return the correct answer, it is not implemented correctly, which I know might be kind of confusing, but something that we have to keep in mind when we're doing data abstraction problems is that there is an abstraction barrier that we don't want to cross, which means that when we create these instances and when we're constructing different instances of different classes, we don't want to go under the hood. What that means is these constructor statements and the selector statements that we created, we kept in mind that we don't want to necessarily look inside them later on. We want to be able to use them and refer to them. I know that might seem kind of confusing. So let's go ahead and work through this problem together. And then I think we'll have a better idea afterwards what I mean by that. Okay, so this is our friends function, and it takes in a P1 and a P2. Then reading the doc tests, this says it returns true if and only if the Pokemon P1 and P2 are each other's friends. So if we remember back to Mentor 7 question 1, when we were constructing these Pokemon instances, every Pokemon instance has an attribute friends, which contains a list of the names of all the friends of the Pokemon. Okay, so basically what this problem wants us to do is it wants us to return true if and only if Pokemon 1 is in Pokemon 2's friends list and Pokemon 2 is in Pokemon 1 friends list. Okay, I think that makes kind of sense. Let's go ahead and look at the current implementation of our return statement here and see how we can change it to be a little bit easier to read and to make sure we're not crossing that abstraction barrier. Okay, so let's go ahead and look, and it says return P1 of 0 in P2 of 2 and P2 of 0 in P1 of 2. Okay, so breaking that down a little bit, we know in our current construction, technically this does refer to its name, and this does technically refer to the friends, which is true about both the first and the second. So one thing we want to remember when we're looking at this is requiring our constructor to never change. If we're going to just be calling straight from the list, and our constructor were change at all, then this function would no longer work because of the way we're pulling from it. Instead, if we think about it, we just created selector statements and selector functions that give us our name and friends automatically. We don't have to necessarily worry about what item of the list it's in. We just know that our selectors we created earlier of P name and P type and P friends will give us what it is that we want. So instead, let's try rewriting this problem using those selector functions that we defined in the last problem. Instead of doing this, let's try instead doing return P name of P1 in P friends of P2. So if we look at this return statement, we know that this here, let me go ahead and switch my color up a little bit. We know that this here will also return the name, and this here will return the list of friends. So it's essentially kind of the same thing we have up here, where we're checking and we're returning true if P1's name is in P2 friends list. Okay, I know this might seem confusing because it looks like essentially we're doing the same thing, but I'll tell you a couple reasons why this works better to do this way. Okay, so it works better to do this way. One, because it's a lot clearer. When we look at this one, we don't remember necessarily what P1 of 0 and P2 of 2 would return. It just doesn't make total sense. And without knowing exactly what is in the constructor, we would not be able to remember what that is. And we wouldn't be sure. And it's just a lot clearer to look at it this way, to use P name in P friends. Okay, a second thing we want to keep in mind here is that what would happen if we changed our constructor statement? If we were to change our constructor statement and alter the lists that we were returning for that, if we, let's say, wanted to add a trainer and we put the trainer in the 0 spot and then moved every other item and every other attribute down one, we would have to go through and change every function we created having to do with these Pokemon instances. What that means is if we created maybe 50 functions, let's say we created our friends, are not friends, that's our type, are not a type, something like that. And we had done that for 50 different questions. If we were to have done this in all 50 of those questions by referring to the specific items in the list, we would then have to go through and find every spot that we called or that we used this kind of implementation, and we would have to change it to fit our new construction. However, if we only used p name and p friends and p type, then we use that in all 50 of our functions. If we did change our construction at some point, then all we would need to change is the p type, the p name, and the p friends selectors, not every single function we created after that. Okay, so I hope that makes a little bit more sense. Let's go ahead and finish writing this problem. So we want to return p name of p1 in p friends of p2, and then let's go ahead and clear up some space here. The last part we want to do is we'd also still want to check and, because we want to check both ways still, and p name of p2 in p friends of p1. So again, this does essentially the same thing that we had up here, but this will just make it so we're not crossing that abstraction barrier. We're not referring to what is going on in the constructor. Let's say, back to what I was saying earlier about the hood, if we were building this instance, we were constructing the instance, if we were maybe car creators and we're creating the engine of a car, we went ahead and we created it and we know what's going on in there, and all we want to do, we have the engine, we have the parts that use the engine, same way here, we create our constructor, we have our selector functions that we can use referring to the constructor, but we're not going to go ahead and refer to exactly what is in the constructor. Instead, we're going to use our selectors here to pull the information from our constructor, so that way we don't have to go ahead and change everything if we had to change something in our constructor. I hope that makes a little bit more sense. I know data abstraction can be a little hard to wrap our minds around, but hopefully that helped us understand a little bit why we don't want to break this data abstraction barrier and how using the selector functions is just a cleaner and easier way for us to write our functions.